At the end of every sentence, they would raise the tone of their voice like it was a question.
Ooh, I
Whether it
think
was a
we've
question or
have we started with you in the middle of your statement, Mr. Prez?
I'm afraid so. They would raise the tone of their voice like it was a
All right, let's do it. Hello, everybody. The gentleman on the Zoom screen with me, my name's Ronnie Herron, represents Santa Barbara's longtime Astronomy and Telescope Club, the SBAU, Santa Barbara Astronomical Unit. And this is our weekly get together on YouTube. We call it the SBAU Astro Hour. Somebody's joining us right now, last minute. It'll be our 225th program for the week of June 16th through the 22nd, 2025. And these are the cosmic topics we are going to handle. We're going to take on, kick around robotic observations of microlensing events, ROME/reactive event assessments, REA, ROMREA. It's photometry of our galaxy's middle, the central bulge, and some local folks being involved. We have a waning gibbous moon right now, and I don't blame it. If I were gibbous, I'd be waning too. Wait till you see the moon's south pole, everybody. Also going to check out this week, Comet 29P is back. Well, it never really went anywhere. We just stopped talking about it for a few weeks. Schwarzmann-Wachmann. M51 is the Whirlpool Galaxy, one of our favorite Star Party targets on Saturday night. Some planetary events like Titan's transit across Saturn, globular cluster M22, and is this possible? We have dark energy, or supposedly dark matter, now a dark galaxy with very few or even no stars. Talk about your hypothetical. And happy summer solstice, everybody. It's this Friday. Let's meet the man in charge, the captain of the good ferry ship, Jerry Wilson. President Jerry, good morning.
good
Thanks
morning. And hello,
putting
Joyce.
Yeah, he's married to Pat Forgy. Also married to Pat as our outreach coordinator, the incredible Chuck McPartlin. And his wife, Pat, is also a merchandise manager and just got elected. It was a real close race over the holidays as treasurer. And who else joined us? Tom Whittemore, who's married to Maureen, baking bread these days, and he thinks he likes that better than teaching science up at Westmont, which he did for so long. And doggone if Bruce, incidentally, Tom's married to Maureen, and Bruce Murdoch is married to Bonnie, and he's also president of the Santa Barbara Theater Organ Society. Hello, Bruce. And joining us
We
last.
just had, by the way, I meant to mention this last week of several weeks. We have an open console typically on the second Saturday of every month. It's free to the public, and you come in, play the organ, we'll give you tours, etc.
What time of day is that?
Oh, from 9 until 11 a.m. on Saturday morning.
And where's the
Okay.
venue?
The Arlington
right?
Theater, that's where the organ is
Okay.
installed.
Okay.
Also,
Well, we're going to have to
tons
get
of-
the word out on that. There's no question about it.
Morning, Tim.
And if this were a classroom, Tim Crawford, if this were a class underway out at Broida Hall, you'd be excused to go to the principal. But welcome aboard and come on anyway. How is your wife, Karen?
Very good, very good.
Okay, everybody's set with their wives except me, but that's okay. I
Tim,
got
you've
my
got
AI.
You've got
What?
your camera set on stop action.
I do. I'm feeling good today. I'm ready to learn
No,
stuff.
no, I mean Tim is.
Oh,
you-
gosh.
You got
I
a
like
new
him so
beret
much.
too.
I like it better when we're not looking up your nostrils, down.
Well, I'm trying to log on to the YouTube side.
Yeah. What does that require? An extra computer? You
Yep.
got your Wi-Fi working double duty here, and you see us? Are you there watching yourself talk on the other screen? Is that how that works?
Yeah, there's a delay, but it certainly works.
Okay. And we just see the original version going out to YouTube that doesn't have those questions on it.
That's
Well,
right.
I thank you very much. It's time to start the hour with some silliness because we like to be in a good mood. And the president somehow comes up with these silly cartoons. Here they are, talking stick figures. You're going to have to increase it. There are two, looks like identical twins talking to another guy saying, "Hey, check us out. I'm the first person ever to clone myself." And the other guy says, "Oh, that's amazing. I bet you're pretty excited about it." The other guy, one of the two, says, "I'm beside myself." Ba-da-ba-dum. And then they silently take a look at each other and he said, "You did this just to make that joke, didn't you? Who do you think you are? Tom Whittemore?" Best $12 billion I ever spent. What does that mean? Is that how much it costs to get a clone of yourself? 12
No,
billion?
they're mocking the billionaires having their own space programs. Here, the billionaire had his own vanity cloning program.
Okay. I remember a Woody Allen movie once about cloning. What was it called? Sleeper, I think.
Yeah,
Remember he had a
that
great
wasn't
line.
cloning. That was cryopreservation after death or something.
Yeah, and I remember he said, I like to clone alone.
Yeah.
That cracked me up.
I want to
This also-
clone Edgar.
Now, this one I know a long time ago we had the same one on, but I thought it was cute.
I don't remember it. You want to talk about it? You want to read it, or you want me
Well, it
to?
just says spotted at the Cleveland Museum of Natural History. It's the way bug collectors, my brother is a entomologist. He does this with sticking the bugs on pins in display boxes and stuff. But way down here in the square is a blow up. And right there in the middle of the square is this bug.
A VW bug.
Yeah.
Well, I remember growing up, I had a collection of little toy cars, and I put a June bug in the middle. Never mind. Let's go to the
Yeah.
next one.
We went down to Chichen Itza one time, and my brother and I, and he was a big butterfly collector at the time. And we weren't getting any butterflies in our nets, but we found that when we drove through the countryside, we got them off the radiator and the front bumper.
Or scrape them off the windshield. They're not quite.
Well, no,
All
they
right,
got to be in good condition to put them up, mount them in a box.
Is this a guy named Louvre for whom
No.
the museum
no.
is named? He just
Uber?
said, go ahead. Somebody else want to read that? Give us your umph.
The
This is
man
great.
who invented the Ferris wheel never met the man who invented the merry-go-round. He traveled in different circles.
Pretty good.
That's for all you punsters out there.
Yeah, well, we got one on the screen. I call them what are more witticisms. Now, this one I didn't quite understand. Is the word cat supposed to precede ions?
Yeah.
Cat
Yeah,
ion.
cations are positive.
Cations. Okay, well, I got
There's
the
anions
positive.
and cations.
Those are the ions
Positive and
back
negative
to the
plates in a
cathode.
battery, for example.
Right.
Mr. President, what is a cation?
It's a positively charged ion.
Oh, they can.
So
Okay, so they can be negative.
it's missing an electron.
Well, this is fascinating as hell. If you took all your DNA, I guess that's out of every cell in your body, straighten them out, put the, I guess, unraveled helix end to end, it would stretch to Jupiter and back 10 times. Good Lord, each one of us, you are neither small nor insignificant. You're just very well folded.
I've
I
never
heard that
seen this particular one with its, that seems hard to believe.
No, I heard that
That's a
even
clever
one.
statement. I'm not sure it's literally true.
Yeah.
I heard that if you just took one DNA, one cell's DNA, and unraveled it, it'd be several feet long. So
I know
trillions.
that's your intestines.
Yeah.
That's your intestine.
Your intestines are like 26 feet long.
Yeah.
Your little intestine.
Okay. Okay, here we go with a Great Northwestern from Upper Canada. Hey, buddy, didn't I tell you a week ago to be out of town by sundown? Cowboy says, yep, but sundown ain't for another 3 months. Well, I'll be out of here by winter, okay? Got several months. And who is this? Edward O. Wilson.
Oh, great writer.
Real problem of humanity? It sounds like a Carl Saganism. The following: we have Paleolithic emotions, medieval institutions, and godlike technology. Boy, that's right on, isn't it?
Yep.
Kind of scary. Could mean the end of us. But we're not going to talk about that today. We're going to talk about Rome Ria and his orchestra, which had its roots, I guess, right here in our community, our area. Not exactly Santa Barbara town, but oh, there it is.
Oh, wow.
This is normally angled in the night sky, isn't it? We
This
don't
is
see it
what?
this way. We don't see it like this flat. It's usually a big angle in the night sky.
But you only see part of it. This you go all the way around. So this point here and this point over here are the same point, and they detach behind your head. So you see it all around, but it's flattened out here, so it's all in front of you.
Boy, this is
Is
This is
this
sure
the
different than-
view from Earth that you would see then all around you?
Yeah, these are pictures from Earth.
Mhm.
Okay.
Then there's the Pipe Nebula right in the middle.
Sure different on the my new computer rather than the iPad. Boy, this is neat.
Mhm.
I'm liking it.
I have a print of this that's a long stretched out, picture that I can put over closets and stuff. That
Yeah,
it's a guy who spent, I think, a couple of years traveling around the world to get all of these, to mosaic this whole image.
yeah.
Mhm.
I
But
had
now
two
all that
in my
all that
office
black and
before.
all that black and dust, are they nebulae?
They're dark nebulae.
Dark, they're
Yeah.
dark.
But don't the ones we look at, aren't they out and away from the central flat disk?
Oh, this is
Ron.
coming out of the teapot of Sagittarius right there.
Mhm.
Yeah.
Oh, there.
Ron, nebula
Yes.
is just a generic term for cloud. Okay.
It's a
So
Latin
dark
code for
nebulae
cloud.
here, planetary nebulae are the things that might not be aligned along the galactic plane.
But if all those stars weren't behind the black and dust that we see on this picture in the middle, would they be colored? Because they're out in a way that normally we see out with blackness behind it. You follow me? And so you see the purples and the yellows. We don't see anything but black on this, do we?
Well, on a dark
Well-
nebula, that's all there is.
Mhm.
You need to talk to Olbers about that.
Well, the way I look at it is it's so thick. The clouds are so thick that the light's not getting through it.
Right.
That's right. The clouds
They're
obscure.
not fluorescing.
Yeah,
It's carbon dust and stuff like that. It doesn't fluoresce when ultraviolet light hits it.
Yeah,
Oh,
it
it's
can't
not getting
reflect
hit by ultraviolet light. There's also hydrogen and other things in there.
yeah. It's also
But the
too
point
far
being
away
is it
from the
doesn't
light source.
fluoresce.
Well, it would if there were a star forming in it.
Oh yeah, right.
So it takes the radio telescopes to see through all that, or the infrared.
Infrared sees a little bit through it, far infrared a little more, radio waves more. So this is the outer reaches of our galaxy. This is the central bulge of our galaxy. And in here, this is like analogous to a gigantic globular cluster in that stars are so close together and so packed that the chances are high of one star gravitational lensing other stars farther away. So it gives an opportunity for us to look at the most common star in our galaxy, but one which we can't see because it's too small, too faint, and too far away. So gravitational lensing lets us look at these things because it magnifies. So a star passing in front of another star is quite common in the central bulge compared to everywhere else. And it gives us a chance to measure the star that's being lensed. And that's what the program is called
Lens.
ROME. It's a gravitational microlensing project focused on discovering exoplanets in the outer regions of planetary systems. It uses a combination of multiband surveys, reactive follow-up observations using the Las Cumbres Observatory network of telescopes. The project aims to find planets between 1 and 10 astronomical units from their stars. That is, they're looking for Earth. It's easy to find gigantic planets very close in, orbiting in some cases a few days around their star, but those are not biologically interesting. A key aspect of this project is the ability to monitor millions of stars in the galactic bulge for 3 years. It was a 3-year data collecting project, creating a massive data set for other galactic science applications. Initial results from the 2017 to the 28 observing seasons have been presented, and recent information from June mentions data with specific fields, including right ascension and number of stars observed. And the reason this is topical is that this data set was finally made compatible with people's ability to use the data, and it was released for public and scientific use. Now,
You
this
suppose
we have here in town in Goleta, Las Cumbres Observatory. And these are the La Cumbres Observatory sites that were used in this project. So this gives, and Las Cumbres gives a continuous observation of something. You don't have to shut down for the night when the sun rises. and then start it up again the next day. The system is online all around the Earth, and when it gets difficult to observe continue observation of an object, it just hands it off to the next site. So they can always get these transient events.
Yeah, their byline is they're always in the dark.
Yes. So
They
there's,
have,
go ahead.
I was just going to wonder, it's 3 Chiles are at the first, and then there's 3 South Africa. Are the Chile telescopes up on the hilltop in the Atacama Desert?
Cerro Tololo.
Mhm.
Okay, so there's a bunch of them down there. They're not on the same mountain, I assume.
There's a whole bunch on each mountain, but there are several mountains. Yeah.
Yeah.
It's very
And here
dry.
they're using the 1 meter telescopes they have around, which is what, about 40 inches or 42 inches. So
39.37.
go ahead.
1 meter is 39.37 inches.
Okay.
Over a yard.
So there's 3 in Chile, 3 in South Africa, 2 in Australia.
Wow.
Does
So
anybody know what that FA stands for?
No, I don't.
Okay.
I think it's in the talking point, but I don't recall
Far away.
it. Far away.
Oh.
Okay.
15 far away is there. Okay.
Now
These are
they
some of
looked in the central bulge, and these are the fields of view that they looked at. They didn't scan the whole thing. Here they are listed or shown on a photograph of the Milky Way's core, the central bulge. And this is an example of the image they get broken down to the pixel level.
Those FA was what field they were looking at.
Oh,
no,
okay.
it's instruments. Okay, never
Okay.
mind. No.
Huh. You introduced the word from the notice, photometry. Is that different from photography?
Yeah, yes. Photometry is a measurement of the brightness of a star, a quantitative measurement of the brightness.
Oh.
But it involves photos. Photo means pictures, doesn't it?
Yeah, you count photons, and the more photons there are, the brighter it is.
Yeah, photo just means light.
So all that little scattered bunch of squares on the upper left became these other 2 pictures, or the ones with the right, upper right?
Yeah, no, for example, here, this section here is 20. And it shows what it looks like.
They blew it up.
Yeah, they just,
Oh,
Got
I
it.
see. It's hard to see because it's a little washed out, but that's
oh, okay, sorry.
I get it. I get it.
Okay.
But the one on the upper right shows the background of those fields you see on the upper left.
Yeah, exactly. Very good.
It's not just one of them blown up. I thought that's what Gary
No,
was saying.
No. The
Oh,
lower left
okay.
might be one blown up, but that's
It looks
Okay.
like they're pretty well 1-to-1.
yeah, they're 1-to-1 on the top 2, but the bottom one might be one blown up here.
Yeah,
Oh, Jerry.
Oh, yeah. Right.
this shows the pixel level.
Yeah.
which is
Jerry,
very
I do have a question in the talking points. They said there was looked at in 3 frequencies, and it was like R and I and G. So is it red, green, and infrared?
Possibly, I don't recall that, but when you're after, photometry has its own, in order so everybody gets the same measurements and it means the same things, they
Okay.
use certain bands to measure the brightness in.
Okay.
So, and all the instruments use those same bands. And
You
this-
see on the left there, it says SDS and then -I-R-G.
Oh,
Ah.
yeah. That's the digital survey bands. What was my thinking here? Oh, that's the problem we run into when amateurs try and successfully do take Hubble data, and they try to make, like us amateurs, we're after a pretty picture in red, green, and blue. Scientists are not after that. So their filters are different than what we look at. So in many cases, there's no direct analogy to red, green, and blue. They're looking at very specific bands with certain spectral characteristics, to characterize the temperature or the chemical composition of that star and get information out of it that way.
Oh, online, Richard says that the FA might stand for focal assembly or fiber assembly.
Could be. So there's a lot of data released on these websites. I did not read all the papers, all of the text, but this shows the transient effect. This is Julian date hours, I think. And this shows the transient effect of one of the lensing in this band.
Mm.
And so you get it, you will never get another look at this transient event. These are just chance things where one star passes in front of the other. And it gives these little brightness things, and they're characterizing the brightness for spectral content and duration and size. So it's a very important data set. We'll see a lot of things coming out of that in the future.
Well, that central bulge is one giant star cluster, isn't it?
It is like that.
Yeah.
The survey
Everything,
itself,
everything moving like crazy because of old SAG-A star.
they're what?
Only
They're
close
all-
in, Ron.
Yeah, they're moving like crazy. I'm sure science likes to conjecture what it must be like to be on an exoplanet with life going around a star that's buzzing around the black hole at the center.
Trust me, you wouldn't want to be there.
I don't think so. It'd be like
The
Io.
radiation will get you.
And you'd be
Yeah.
there for a very long time.
Oh,
So this is
The
the
night sky.
author on the paper and the director of wrote up the research is Rachel Street. She has come to our club several years ago. Excellent speaker. So for those of you that remember,
she also helped Zoe, that student that was trying to image the exoplanet for
that's
her
right. So
science
that was
fair.
2014.
Yeah.
So next, the waning gibbous moon.
Ooh. Is it waning up there again?
Yep. So this is
Waning violets, Ron.
Yeah, right.
this is tomorrow morning at 2:00. And the moon is down here. It's just passed by Pluto, moving down this way. It's very low in the sky in the south. And that gives us, we're not as interfered with by the full moon as we would normally be if it were farther up in terms of outreach and looking at faint fuzzies. Now this is the gibbous moon on the June 16th tonight. I think, yeah, 9 p.m. And you can see down here in the Southern Highlands, as it's called, this is a mapping, not a photograph. And this is Clavius down here and Tycho. And these are both photographs. This is a close-up of the South Pole region. This is Tycho here, which is very prominent. It's more prominent than this in reality. It's a bright crater. And this is Tycho, made famous in the
Clavius.
what?
Clavius. The Tycho again. Yeah.
Yeah, Clavius, right.
2001 Space Odyssey.
Yeah, 2001 this is where they dug up the
Well, it's still there. It's waiting for us. I know it's up there.
I think so, yeah. I haven't seen any of those TWA spaceships getting ready to go up to the space station, though. But this is a picture of Tycho taken by Robert Cazalet. I spelled his name wrong. You won't see it wrong. It's all right here. But it's a very dramatic, very nice picture. He does excellent work in planets and the moon. And this is a picture of Clavius, and it's got this spotting feature of this little ring or little arc of descending crater sizes. No other crater has this that I can recall. So this is, when I see this, that uniquely defines Clavius.
No
Quite an
kidding.
old crater.
Wow.
Corona Borealis on the moon.
Yeah. We're waiting for
Can
an
you,
extra one to appear.
Yeah,
Yeah.
is there a name, a scientific name for the little bump you get in the middle at the close of a raindrop on water, or the earlier crater showed it, but this one doesn't have it. You know what I'm
Central
talking
rebound
about?
peak.
oh, a central,
What's it-
there's kind of a faint one here.
Oh,
And up here, there's kind of a faint one.
okay. Does that mean that it was liquid, but froze back into solid before it could go back down?
Yeah, pretty much.
Really?
If you,
Well, it was mush that came up and sort of sit there and then it froze.
when, when I was going through calculus and for the first time as a freshman, I was so excited by what I could do with calculus that I calculated the speed based on the amount of mass in, for example, in the Andromeda galaxy. I calculated the speed of the outlying stars based on Newton's laws. And I kept getting the wrong answer because the answer I got was that the outer reaches were moving at the same speed as the inner reaches. And I thought, okay, I've got more calculus to learn, and I threw the whole thing away. So then, and also when I came across things like this, I figured out from the impact speed of the objects and the mass of the object, I figured out how much heat was released if you had perfect conversion of kinetic energy into heat, and what the melting temperature of the rock and the asteroid was. And you easily can see that they both act as a liquid. There's so much heat involved.
Well, it would be my understanding that the inner planets of a solar system like ours could be moving the same speed as the outer planets. It's just that we've got a quicker track. They got a longer route, but is that not true?
It's not
Does
true the
not
way
only
you said it.
does not only the orbit get bigger and they got more time to
They're
track?
moving at a slower speed.
Okay,
If
so
they
the
were
stars.
obeying, Kepler's laws, the ones that are further out would be traveling slower and they'd be dragging behind.
Oh, well,
And they don't.
that
What
makes
I've done
sense.
with the speed of the stars around the Andromeda galaxy was the same thing that led Fritz Zwicky to say there's missing mass. But I assumed that it was missing calculus in my brain, and so I didn't tell anyone I got that answer.
Well, I don't know how you see any speed in stars at all. They just seem locked in wherever they are.
Doppler effect.
Can I ask a
Uh,
question about these impacts? If you're in an atmosphere like the Earth and you get an impact crater like this,
Yeah.
that shock wave travels out in the atmosphere. What would happen here with no atmosphere on the moon? Same thing, or
Well, you'd get a lot of gas evolved, so you'd have a shock wave.
okay?
I don't know the density of it. I didn't calculate that.
But
Well,
you
Tycho,
definitely get a
the
moonquake.
ejector rays go all the way to the
Oh.
North Pole of the moon.
Yeah. Yeah, there's a lot of energy out there, and it depends exactly on what the tensile strength and other properties of the impactor are and the
Yeah.
moon's materials.
well,
What
Mr.
I
President,
like is the way there are a couple craters on the moon where there are two craters right beside each other, obviously at the same time, because the blast product goes straight out between the two craters.
Huh.
The craters are here and the blast effect goes out that way. So they obviously landed in as a set.
Hmm.
So you can see a lot just from this. I went out back a lot into my backyard to my mother's chagrin and made big fields of mud and then threw mud into the mud and made craters, trying to get different, oblique angles and things hitting at the same time. So,
There's a whole National Geographic video on cratering where the scientist went and fired a rifle into sand and at various angles and looked at what the cratering looked like to
mhm.
study craters on the moon.
Now,
really?
they did that also for a non-crater on the Earth from the Tunguska event. They took the pattern of trees. It knocked over a lot of trees. And they were able to find that it was an airburst over an exact spot where it was, and the angle that it was coming in at, and estimated the speed that it was coming in at. So it was a good detective work.
Could they estimate the size of the rock?
Yes. I
They
don't
don't
have,
know exactly what it was made out of, so you have some assumptions there, but yeah.
yeah.
They
Well, they
did
did
some.
find tektites from it, I think, scattered around.
There was something kind of similar to that. There was one guy I saw on TV that did a computer modeling and a test of when Theia hit the Earth, creating the moon, and he just said it couldn't come straight in because it
No.
would just pulverize the Earth. So
Well, it melted everything anyway as it
Yeah.
hit.
I don't, yeah, I consider the earth pulverized in that event, but
well, he
Yeah.
was just saying that there had been nothing left of the Earth, and
okay.
so he did a bunch of experiments and he finally figured out it had to be coming in at this speed, at this angle,
Yeah.
in order for it to work right.
There are very nice simulations online that you can find that illustrate that calculation.
And
Yeah.
what you have to match up to is the angular momentum of the moon and the Earth and the tilts and all that. So
Yeah.
that's more what determines it rather than whether we would have got, because everything got molten and turned into a big cloud of vaporized rock.
Well, if we had an asteroid of any size, really big enough to come into the atmosphere, but just sort of glance through over to space, we'd have a light show. If it didn't hit the Earth, in other words,
Oh,
but really went in.
Ronnie, there is one of those. Look up the Teton meteor. There was
It was
one that
seen-
was seen over Wyoming that came in and skipped through the atmosphere.
Well, that would mean a meteor more than just a second or two. It'd probably last for minutes, wouldn't it? It'd be
Yeah.
a streak.
Yeah, there's
Process.
videos of it where people realized it was there and started videoing it.
Whoa.
And it went back out again.
Yeah, it went back out.
I seem to recall that.
Wow. Nobody had a video running. We didn't have
Oh,
cell
they
phones.
did.
They did. There's video of it.
There is,
Yes.
but not a cell phone video.
Not a cell phone video. No, not for the 70s.
Does somebody happen to have a camera going? Wow.
Yeah, it was at some resort, like Jackson Hole in Wyoming.
Well, Chuck, here's your favorite diagram of the night sky.
God, unusable.
Well, let me point out Regulus and
Right.
east and north. So it's
And
not
tonight,
really,
Regulus and Mars will be pretty close to one another.
And
Yeah.
they were last night, really close.
They were, yeah, they were
Oh, okay.
when we were at.
Oh,
Oh, there you go.
Refugio.
Yeah. So
Oh.
this is actually where they also talk about a galaxy in here, and the cursor is on NGC 3049, which is very close. So Regulus and the comet is right about in here. So it's south and east. I don't mark it on here, but anyway, south is this way and east is this way, I believe. Anyway, so Comet Schwarzmann-Walkman, there's several of them up there. This is Schwarzmann-Walkman 1, and it was discovered. It's a comet that goes through regular outbursts. It's normally about 15th magnitude, but and I think it's a centaur, meaning it's between Uranus and Neptune or Jupiter, and it pulses. It does something where it has outbursts, and then it comes up to about 13th magnitude. So Astronomy Magazine suggests that you watch it over this month and see if it, because it's well placed. And we're getting into darker skies. So you should be able to see if it's going to have an outburst. It should be dramatic. It does not have a tail.
What causes those?
What causes that outburst?
Yeah.
There's a big lump of volatiles on the surface that's frozen, and the thing rotates into view of the sun, and then it boils off, and it gets this big geyser going off.
Or another explanation I've heard is that it's fluffy. It's not packed solidly. It's not dense, and there are caverns or the equivalent of those.
Yeah,
And they can heat up and collapse, and then you get a big outflow of stuff.
I'll buy that.
Hey, Chuck, on Saturday, Mars was right next to a star. Was that Regulus that was next
Yes.
to it?
Yeah.
Oh, okay. That I didn't know. I was wondering what
Right
that
there, you
was.
see Regulus and Mars,
Yeah.
and this is tomorrow night at 10 p.m.
Okay.
So
So it's been moving from, down by where the EG is in Regulus, and now it's right up above the star. So the other night when you were looking at it, it was down like below the G in Regulus.
Yeah, it was. Yeah, exactly. It was like they were kind of side by side. I just didn't know what it was.
It was more to the east of Regulus. You're talking about when we were at Refugio?
No, we're talking about the star party at the
At
museum.
the Star Party. Yeah, at the museum.
Oh, okay.
Oh, actually, from this, you can tell that this is west going down that way. East is
Okay.
going up this way,
Okay.
and
Yeah.
south is that way. So this is NGC 3049. It's obviously a barred spiral. Quite a nice object. This is a picture from the Sloan Digital Sky Survey. And the next picture is actually a picture of Comet Swassman-Wachmann during an outburst.
Really?
Go ahead.
And no tail, you said.
No tail.
Why is that?
Tail, it's pointing away from us.
It's
Oh,
pretty far out, Ronnie. It's out between Jupiter and Saturn somewhere.
Yeah.
you suppose old men and Watchmen and Watchmen are still alive?
No, they're 1800s.
Yeah.
No, they got
Oh,
hit
no.
by a comet.
Yeah.
They
So,
discovered that? Okay, it came.
they were walking around at night looking straight up into the sky and walked off a cliff. So they're, but anyway, this picture was taken by the Gemini North Telescope, which, as you may recall, is an 8-meter aperture. So it's this is not a picture you're likely to get with your
Your Astro scan.
yeah.
What's the orbital period? How often does it come back?
I don't recall that. I'm not sure it's ever one that ever goes away. It kind of goes around at that same distance.
Yeah, it's in a pretty circular orbit, and I think it's 7 years.
So is it in the plane of the solar system? Is it just like orbiting like the planets in between
It's
their
orbiting like
orbits?
the planets, but I don't think it's in the exact plane. It's probably, something that got kind of captured by Jupiter's gravity and affected it where it ended up.
So it could just be an asteroid with water on board, right?
That's what centaurs are.
Yeah.
Oh, is that the word centaur? I heard you use that. I didn't know what you were talking about. A centaur
Actually,
is a
this may be Jupiter trying to steal one of Saturn's moons.
Yeah.
about minotaurs. Those are what are those? Half goat and half man or something, and
Half bull.
half bull. Okay.
That's a lot of bull.
Now, this is tomorrow night. This is at 10 o'clock p.m. This is a this is a view of the northern sky. There's Polaris right there. And here is the Big Dipper with its handle going up there. And the topic here is one of those beautiful things, pink fuzzies in the sky, M51, which is a double set of galaxies. Actually, this is the brighter of the two. And it's near Alkaid, but these two stars here, you go up and you go out at about an acute angle, not 90 degrees from this line, but you go back. It's an easy object to find visually if you don't have setting circles or go to, because you can just see this line, you go at this angle down that way, and it's usually right there. It's in a region outside of the Milky Way, near the North Pole of the Milky Way. And so the galaxies, our galaxy's star clouds do not interfere. You can look out into intergalactic space. And so there's a lot of these other galaxies out here that are also very nice objects to look at. Even down here to, well, you can see M81 and M82. One of them is Bode's galaxy. The other one, I forget if it has a popular name.
Cigar.
The little
Oh,
cigar.
that's right.
The little cigar.
Right. And M108 and Hilton Hotels was giving me a telemarketing call.
I'm sorry, did I miss something? Are the yellows all galaxies?
No,
No,
they're Messier
Those are
objects.
Messier
Oh,
objects.
the Messiers. Oh, okay.
I'm looking for 101, but I don't see it.
It's up there.
It's to the right of the
Oh, there it is.
Alkane.
Yeah, yeah. That's right. It's easy because it makes I couldn't find it because it's easy. It makes a equilateral triangle with these two stars also. So M51 on that side, M101 on the other side. M101 is bigger, a little fainter, but it's still a dramatic object.
I didn't know that hop. That's a good one, Jerry. Thank you.
Yeah. Those are there's about 6 of those I've memorized for outreach when my battery goes dead or something doesn't work. When I went to outreach, lifting that stuff around and putting it up is getting to be a burden at my age.
Yeah.
So anyway,
We're all
this is a picture, a very dramatic picture of M1 of Messier 51. And the little guy on the left is NGC 5195. They are connected by this arm, and this one, the little one, is behind the big one. So they are, I think this one is moving far, they're moving away from each other, but along our line of sight. And you can see all this haze out here, which are actually disrupted star clouds from the interaction where the two cores fought with each other for ownership. You can see it way around here.
They didn't collide or merge.
They didn't actually hit each other, but these stars here actually passed through the combination where the gravitational force was about equal.
Okay.
Very nice lenticular galaxy down here. And then this one, that looks like kind of a dumbbell galaxy.
Yeah.
Oh, and then there's a nice spiral up here, looks like, near the edge on. A lot of structure up here. And if you take there's a nice little galaxy. If you take a picture of this, you will be able to see probably 2 or 3 dozen galaxies in the background and a little wider field of view than this. But an excellent thing. It shows the yellow colors common to the core of galaxies, spiral galaxies, with older stars, and then out here the red of hydrogen regions of starburst nebula and the dark nebula that's not lit up by luminescence, and then the blue from the young stars that are created out here.
Wow. So would it be fair to say, Mr. President, that most of the galaxies out there that I've always considered just individual rogues are mostly parts of systems that are similar to stellar systems, like our solar system? Some of them are orbiting. There's local groups.
That exact question is a hot topic in today's galactic research. They keep finding bigger and bigger and bigger congregations of things that are believed to be part of a big structure that is much bigger than our field of view of the galaxy, of the universe. So I can't answer your question. I don't know if most of them are.
Can you answer me this? Do they know how many collisions are happening right now? What percentage of all the galaxies we see are actually merging doubles well, this one's not merging though, they're separating, right?
They will eventually merge. They just happen to be separating right now.
Yeah.
Oh, okay. And we've merged over the millennia, haven't we, with we've accepted small galaxies that became globular clusters.
Even against their will, yes.
Okay, against their will. Fascinating. There it is.
It's really washed out.
Okay.
That's better. Were we going to see a transit there of Titan?
Shadow transit, yeah.
Is that better?
We're not seeing it.
Oh,
No, it's you.
Share it.
Feel it's coming.
There it is.
Okay.
You got it.
Now, because Saturn just passed through its zero ring thing in March, it's a low angle for its ecliptic. And so that means that there's a lot of activity in both the moon passing in front of Saturn's ball, but the shadow, seeing the shadow at the same time, is also transiting. That's only for a period from now through October that you're going to see some of these shadow transits and the moon transits. They, for example, here, this is at 5 a.m. Eastern time this morning, so this is over. You missed it. But this is Enceladus shadow, and this is Enceladus right there. Now, these will continue with various moons, so this is still a good thing to show, but you've got to go to a site that has the ephemeris for these shadows that lists when they're going to happen. I have this on my iPad. It's called Saturn Moons, and it's a thing you can set the date and time, and you can watch. You can change the time, and you can watch the moons approaching and see when, and then you can try and get up and figure out if that's visible for you where you are, or if it's being only shown to India, for example, stuff like that. So if you're into that, they're cool things to watch.
But a question, would this be a good opportunity to examine and figure out more about Titan's atmosphere going across a bright disk like Saturn with the
No, I don't think Titan transits, but its shadow does.
Yeah.
We're not looking at the planet there, or we're seeing its shadow?
We got a real good look at Titan's atmosphere when we landed a probe there.
Yeah.
That's true. That's 20 years
I
ago.
don't think there's much for us at that level to get from a transit.
And it's mostly what, CO2?
No, methane.
Methane.
It's
Oh,
a
methane.
nitrogen-rich atmosphere with a lot of hydrocarbons in it.
Wow. And we're going to go there someday.
I think so. Martin may discuss that because that's a candidate for helicopter probes.
Yeah.
And I know there are several projects that were being done to develop those kinds of probes and fund those kinds of expeditions. But with NASA being basically cut off at the knees, a lot of these things are stalled.
Yeah. And when our friend Julian Knott was alive, they might have sent balloons.
Yeah, they were actively considering that.
Yeah, that's right.
Oh, thanks, Ronnie. I forgot his name. Julian Knott. Yeah, he was a good old guy.
Seems to me any balloon that would go to Venus would be burned up and popped.
No, you stay above the hot stuff.
Yeah.
Oh, the hot is the 900 degrees is only down at the surface. So.
Yeah, it's global warming down there. It's a runaway greenhouse effect. It's in the Republicans' nightmare.
That's our future. Yeah, you're right. Oh, I love this program.
Okay, this is Messier 22. Let's get control of magnification here. This is midnight, 12 a.m. And we have in here with Sagittarius rising. This will be higher, more prominent in the evening skies in a couple months, earlier in the evening. Now it's a midnight to morning thing. And M22 is one of the globular clusters right here that's in the Milky Way core. This is, as we've done covered many times, this is the teapot asterism, and it's right for looking like a teapot with a handle. This is my handle. This is my spout. Here's the Milky Way coming out. So this is right in here is the core of our galaxy, actually up in here. And this is the central bulge represented in this planetarium program. M22 is a very easy object out in this area. And this is what it looks like in a wide field. It's a very dense object. It's quite bright. It's magnitude 5.1, which means under a dark sky, you can see till magnitude 6. sometimes with some people's eyes a little farther. So you could pick this out as sort of a fuzzy star.
Huh.
Mhm.
They don't think it was a former captured dwarf galaxy?
Could have been.
Wouldn't they have their own little direction, their own trajectory versus that would be different from the stars around them?
It does.
Oh,
Its orbit around the Milky Way is not in the Milky Way plane. They occupy a spherical cloud like the Oort cloud around our sun, but they
okay.
occupy that around the galaxy. By the way, I read something the other day on the internet, so I haven't decided if it's researched it to know if it's true or not, but someone claimed that they spotted spiral-like structures in the Oort cloud instead of it being a continuous shell.
Yeah, that seems to be a valid thing. And you read about how they discovered it, right? They took a bunch of data from these positions that they had for Oort cloud objects,
Yeah,
and they were making a display at a planetarium in New York.
yeah.
And so they put in all these accurate coordinates, and when they threw it up onto their dome, you could see the spiral structure,
Mhm.
which nobody had noticed because they hadn't tried to visualize it. They hadn't
Right.
put it into a
So
visual.
it looks like arms on a galaxy?
Yeah.
Wow. Have the Voyagers gotten out through the Oort cloud
No,
yet?
nowhere even close. The Oort cloud is 2 light years in radius.
Yeah, it's halfway to the Alpha Centauri.
But even though it's connected to our sun, it's part of interstellar space, I think they say.
No, that's just because they say the Voyagers are in interstellar space, just because they're outside of the sun's magnetosphere. But that's
Yeah.
kind of a weird way to say it.
But basically, all it is a big version of the Kuiper belt or the
Except
ring.
except more spherical in distribution, yes.
Wow. You can't see it, you can't photograph it, so somehow they know this.
They
Well,
measure it and plot it.
yeah, you can see individual elements out there, individual
Okay.
pieces that are big enough.
And a
And you can
planet.
infer from comets coming in.
Got it. Wow.
Oh,
I
that's
wonder if there's
cool that it has the moon in it.
This is an old picture. This is not current. But this topic here is noctilucent clouds. Apparently, this season is a season where they're more likely to occur. Obviously, an airplane making its way through down here in this time exposure. But this was, see, I think I said where it was. Oh, yeah, this is from Orlando. An amateur, Paul Poteet from Orlando, Florida, took this.
And to see it at low latitudes is pretty amazing.
Yeah.
what is it?
It's just a cloud, but it's so high up that the sun is set for the world, but this is above the level of cirrus clouds, and it's still in sunlight up there.
Do you ever memorize the names of the clouds, the Nimbus, the Cirrus?
Once a long time ago.
Hey,
About
Tim.
Grade school.
Hey, Tim,
Stratocumulus.
this looks kind of like the witch's broom, right? Or Pickering's
It does.
Yeah, it does, doesn't it?
Yeah.
Yep.
Yeah.
There's 52 Cygni up there.
Yeah.
Yeah, they have some of them form that look like giant UFOs.
Yes, that's
yeah.
something I meant to mention earlier. We were talking about that asteroid that entered the Earth's atmosphere and exited in Yellowstone or Yosemite or somewhere, but it was before cell phones were common, and so now everybody has a cell phone. There is nothing that's going to land here without it getting photographed. And yet the UFOs are still faint, fuzzy, ill represented something. So there's been no improvement in them, which means they're just a screwed up photograph of some type.
You don't think they'll land in smog or foggy swamps where only some rural farmer gets to see them?
Oh, you saw that comedian James, forgot his last name. redneck comedian. It's just hysterical. He talks
Oh,
he talks about a family that, is coming of aliens, and they said, he's telling the kids,
Jeff
we're
Foxworthy.
not, yeah, you go to the
Jeff-
bathroom now. I'm not going to stop at every planet we come to. And so they come to Earth for a vacation, but they don't go to Disney World or they don't go to Magic Mountain. They go to a mud patch out behind a pig farm in Arkansas.
I believe that might have been Jeff Foxworthy.
No, it wasn't him. It was another guy. He was very obese. He passed
Oh,
away a few years ago.
Tell me it's not the cable guy.
No, it's not him. He's very obscure. Probably you guys have never heard of. Maybe someone stole his gig. Anyway, we are looking at here. This is a photograph, and in here, I've tried to find the right ascension and declination of this, because this is really not very handy, having galactic latitude and galactic longitude. But
Is this the galaxy without planets or without
possibly,
stars?
this is the best candidate for that.
Okay.
There's things called HVC, which is high velocity cloud. They're gas clouds.
That are huge.
What's that?
That are huge, like
Yeah,
the size of
they're small galaxy size. They're gas clouds. They're outside of our galaxy, and they're trying to decide if any of these gas clouds are actually galaxies without stars. They're just dark matter galaxies.
They're just forming.
I don't know about that, where it is in its history, but there are 3 of them: HI1225 plus 01, AGC 229385, and this one, which is AC G185.0-11.5, which is the most recent and the most promising candidate so far. And these things are detected in studies of quasars. So it's a complex. Now, in the other ones, the other candidates they've looked at, and this is a close-up photograph of the most likely one, the other objects have been shown to be just clouds of gas. There's no real stars in them to speak of. There's stars everywhere a little bit. But this one seems to be rotating. It has a rotational speed and a slight spiral structure to it. So this is the most likely candidate. So they're moving. It moves at 230 to 235, from 150 to 235 kilometers per second. So they're high velocity clouds. This one has a column density mass, 10 to the 20 per square centimeter, shown there on the right.
So it's headed somewhere, I guess.
Yeah.
But it looks like a precursor to galaxies right after the Big Bang. This was the first step.
No, this is something where there would have been a galaxy, and there's a line right across there. Anyway, it looks like these were once a galaxy. The speculation is the galaxy had collision with other galaxies. The stars all interacted. The dark matter did not. The stars were all flung away, and now we have just a galaxy of dark matter left. The idea that there's a dark matter galaxy is a hypothetical idea, and they've been looking for it among these high velocity clouds. And this is the best candidate for it because it has rotational motion to it.
So dark matter we can't see, but what we are looking at is our gas that's left, gas and dust.
Right.
Wow. And it can't make any new stars, or is it making them?
And I don't think it's dense enough for that. You know, it has to be pretty, like the Great Nebula in Orion is pretty dense compared to this. And something has to happen in the cloud, like a shock wave goes through it, in order to get the gas to have turbulent motion and start clumping.
Jeez. Well, I can't get over it. It looks great. Wow. Is it everywhere, scattered all around us, or is it only in one area of the
No,
sky?
I could not find any locations for any of these three high velocity clouds. And I asked Meta AI what the position of it was, and it came back and said, I can't find any data on the thing. Sorry about that. And I said, well, thanks, but you know, they said you might look around on the internet, and I said I already did. You were my last hope. And so Meta apologized and said, well, if you find it, let me know.
And then they have discovered galaxies out there that don't have any dark matter in them somehow. Yet they're not playing a part. I guess they're not, or maybe they are.
They found galaxies with dark matter distributed largely around or outside of the galaxy. I've seen maps
Not
of
in it.
that. This is all unknown stuff. It's current things, you know, that people are looking at. So it's
It's a great show.
Yeah.
Well, Chief, I can't wait for the test. It'll be several weeks away, thank God. I'm writing things down on my hand, and I guess that does it for the show. Listen, well, let's do 226 next week, shall we? Gather
Okay.
here on the screen, and you did good, all of you. Thank you very much. Chuck, how do we like to say farewell in our language?
Hasta Nebula.
Hasta